let's look at this next group of problems and kind of bring those two ideas together. So we have this problem here, and they're asking us to find the x-intercepts and coordinates of the vertex of the parabola, right? So to find the x-intercepts, given this equation, so if we want to find the x-intercepts, we know that we need to write it in factored form. Y equals a times x minus x1 times x minus x2. And you'll notice that I've factored any a out front. So that makes my job just a little bit easier. Okay. And let's look at what that means for this problem in particular here. So I have this y equals negative x squared minus 2x plus 15. So my a is negative 1, right? And I want to get that kind of out of the way because I like for my a to always be positive 1. So every single time I'm going to, if it's not positive 1, I'm going to factor that out of there. So if I factor a negative 1 out of all these terms, I get x positive x squared plus 2x minus 15x. Now I'm just going to work in here. I'm going to keep bringing my a down, right? My vertical flip. And I'm just going to work inside here, and I'm going to factor this. Now that my a is 1, that job gets to be pretty easy because I'm just looking for factors of c that add to b, right? Which in this case would be factors of negative 15 that add to positive 2. Well, those factors are going to be positive 5 and negative 3. And if you're not sure about that, you can go through the order 1 and 15 and all that kind of stuff. But because it's negative 15, I know that those signs are going to be different. And this 2 is going to represent the difference between those two. So the factored form of this is x plus 5 and x minus 3, like that. So that tells me that I have x-intercepts at negative 5, and I have an x-intercept at positive 3. Now, so if I was graphing this, I could bring this one over here. We'll say that negative 5 is right here, right there. Positive 3 is right there. And I know that my y-intercept is positive 15. It's right there at the start. And so that goes right about there. So that's the information that I have so far. Now, it also asks me to find, this question also asks me to find the vertex of the parabola. And we've talked about that a little bit. If I want to find the vertex of this parabola, then I'm going to go ahead and I'm going to start with that same beginning point, and I'm going to complete the square. And remember, when we complete the square, we focus kind of on these two terms here. So I'm going to scoot that guy over there. And I'm actually going to do the same thing where I'm going to factor out that negative 1. So I have x squared plus 2x. Now remember that when I complete the square, I'm trying to rewrite this as a square of a binomial. This sign's always the same. And the second one's always going to be half of this. So half of 2 is 1. 1 squared is 1. I've actually added negative 1 to the equation, so I need to add positive 1 to the equation. And then I can add these together, and I see that my vertex lies at negative 1, positive 16. So I can go back over here. Negative 1, positive 16 is right there. So now I can mirror some points and sketch my graph. Kind of like that. Okay. But they just asked for this information that we already have, which is the minus 5, the x-intercepts at negative 5 and positive 3, and the vertex at -1 and 16. Let's look at one more problem type, and then we can close out this bit. Now, let's go. So this is basically undoing what we just did, okay? And we should be pretty facile, kind of moving between the three different forms, okay? So let's look at what this problem says. So we're going to go from f of x equals -2 x minus 3 squared plus 7, and they want to turn it into standard form. So what we're going to need to do is kind of expand all this and combine like terms. Now, probably the trickiest part of this is this idea. This x minus 3 squared is the same thing as x minus 3 times x minus 3. And then I'm going to move that plus 7. So I'm going to deal with this part first. Okay? Some people are tempted to distribute this in, but I would wait and do that until the last step. So if I multiply this out, I'm going to get x squared minus 3x plus 9, or x squared minus 6x plus 9 plus 7. Then I can distribute this into all the terms, and I'm going to get f of x equals -2x squared plus 12x minus 18 plus 7. And then I have these two like terms, and all of a sudden I have f of x equals -2x squared plus 12x minus 11. Okay? So now I have rewritten this in standard form, in that ax squared plus bx plus c form. Let's see what's next. We'll look at one more of these. That's basically the same. So let's talk about, well, what if it was something like this? The process will basically be the same, but what if you had y equals negative x minus 3 x plus 5? Well, I'm just going to do the same thing. First thing I'm going to do is FOIL all that out. X squared plus 5x minus 3x minus 15. And then y equals negative x squared plus 2x minus 15. And then I can distribute that in and get y equals negative x squared minus 2x plus 15. And then it would be in standard form. All right, well, that will conclude our discussion of section 11. Hopefully this will be helpful for you.